This is section 6.6, evaluating polynomial functions. We're going to do something different, something you haven't done before. It's called synthetic substitution. We're going to use it to evaluate polynomials. The homework is 1 through 12 in the homework packet. Before we get started, we're going to talk about types of polynomials. This is a little bit of a review. You should have seen this somewhere before, but just in case you don't remember. If I have a function like y equals 4 or f of x equals 4, remember y and f of x are the same thing. So if I have y equals 4 or f of x equals 4, this is what we call a constant function. Has degree 0. If we have something like f of x equals 2x plus 1, notice I do have an x to the first power. We call this a linear function. Has degree 1. Notice I have degree 1. Leading coefficient, that's the number in front of the highest power of x. Leading coefficient for this function is 2. We have quadratics. We've done these before as well. The highest power is 2. That means the degree is 2. And the leading coefficient is negative 1. Something we haven't talked about is a cubic. We have an x to the third power, degree 3. Leading coefficient of 6, and a quartic, which has x to the fourth, is the highest power. Degree is 4, and in this case, leading coefficient is negative 7. Depending on the polynomial, it can be easier to evaluate or plug in a number using a process called synthetic substitution. Before we talk about synthetic substitution, let's review how you would normally evaluate for x equals 2. Normally, we would take the 2 and we would replace our x values here with 2. So we replace, replace, and replace. Then it's simply a matter of order of operations. Exponents come first. 2 to the fourth is 16. 2 squared is 4. Multiplication, we multiply 2 times 16, we get 32, etc. Combine, and we get 18. All right, so this is what we've done in the past. We've done this many, many, many times. Today I'm going to talk about something evaluating in a different, completely different manner. So, first thing you want to do is rewrite the polynomial with any missing terms with a 0. So let's say, for example, I have 2x to the fourth, but I have an x squared and I don't have any x cubes. So I'm going to write that as 0x cubed. I do need that missing term when I do what we call synthetic substitution. Here's a hint. If I have an x to the fourth, I need 5 terms, one for each power of the x. We have an x to the fourth, x cubed, x squared, x, and don't forget the constant. All right, so we have 5 terms. And we're going to look at the coefficients. We're not going to take and write the variables. What we're looking for is just the numbers in front. So the numbers in front, 2, 0, 1, negative 12, and 6. So we're going to write those in a row. And then we are going to draw a giant L like this, leaving a little bit of space underneath this row, because we are going to write numbers down here. All right. So we're evaluating for x equals 2, so we're going to take the 2 and put it on the outside. That's what we're evaluating for. Next, the first number we don't do much with. The first number, it's going to just drop straight down and we're going to rewrite it underneath. Here's where we start doing the synthetic substitution part. We're going to take this number here and this number here and multiply them together. Notice I have 2 times 2. 2 times 2 is 4. I'm going to take that 4 and write it underneath the 0. So this number times this number, and write it here. 2 times 2 is 4. Now I'm going to take these numbers and add them together. 0 plus 4 is 4. I'm going to write it underneath. So here's my 4. I'm going to repeat this process over and over again, where if the number is below, it gets multiplied to that number there. 2 times 4 then is 8, and I'm going to put the 8 here. So here's my 8 right there. The numbers that are inside get added together, so 1 plus 8 is 9. And I'm going to repeat. So I'm going to multiply the 2 times the 9. 2 times the 9 is 18, and I put it under the negative 12. These two numbers that are inside get added together. Negative 12 plus 18 gives me 6. If it's outside, they get multiplied. 2 times 6 is 12. Inside, they get added together. 6 plus 12 is 18. What I want you to look at is the very last number at the bottom. This number is 18. Well, it turns out it is not a coincidence that it is the same as when we plugged 2 into that function. So this is the process that we call synthetic substitution. Rather than substituting normally, we're going to substitute synthetically. So example 1, we have negative 3x cubed plus 2x squared minus 5. We want to find f of 4. So what we need to do first is figure out how many terms we need, see if there's any missing. If I have an x to the third, I need 4 terms. So 1, 2, 3 terms means there's one missing. We have to figure out which one's missing and put a 0 there. So if I have an x cubed, that means I need to have everything underneath an x cubed. So do I have an x squared? Yes. Do I have an x? No, that's the one that's missing. Negative 3x cubed, 2x squared, our missing x, we got to put a 0, minus 5. So remember, we take our coefficients and write them in a row. Negative 3, 2, 0, negative 5. Draw a giant L. The number that goes on the outside is what we're evaluating. So we have x equals 4, so I put a 4 on the outside. All right, now that we've set it up, we need to actually do the problem. So the first number, we don't do anything to. We just drop it right down, and we have negative 3. From here on out, if the numbers are on the outside, they get multiplied together. If the numbers are on the inside, they get added. So 4 times negative 3, so 4 times negative 3 is negative 12. Numbers inside, they get added together. So these two numbers get added together. Gives me negative 10. Now I've got a number on the outside again. So 4 times negative 10 is negative 40. Numbers inside get added together. And numbers on the outside get multiplied. So 4 times negative 40 gives you negative 160. Numbers on the inside, they get added, negative 165, and your answer, f of 4, is equal to negative 165. Here's your answer right there. Let's do another example. Suppose we have negative x to the 5th, negative 4x cubed, 6x squared, and negative x. So if I have an x to the 5th, that means I need 6 terms. So I'm going to have a negative 1. Notice I have no x to the 4th, so I'm going to put a 0. Negative 4 for my x cubed. 6 for my x squared. Negative 1 for my x. And I have no constant, so I need to put a 0 there. So count up, make sure you have the correct number of terms. So you have 1, 2, 3, 4, 5, 6 terms, which is what we needed. So we're going to draw our giant L, and the negative 2 goes on the outside. So from here, remember the first number just drops, so we've got a negative 1. If the numbers are on the outside, they multiply. So negative 2 times negative 1 is 2. Numbers on the inside get added. 2. Now we have a multiply, and now we have an add. Multiply and add. Multiply and add. And multiply and add. And 90 is our answer. I'm going to have you do example 3 on your own. See how you can do that one. See how you do on that one. Example 4, try it on your own. And let's take a look at example 5. Suppose I have x cubed minus 3x squared plus 4x minus 2, and I want to show that f of 1 is equal to 0. When it means show, I already know the answer. I already know that the answer is going to be 0. But it has to be proven. You have to actually show the work to me. So the 1 drops, we multiply, we add, multiply, add, multiply, and add. And the last number is indeed 0. So if this last number, if it happens to be a 0, we say that 1 is a 0 of the polynomial. I'm not saying 1 is 0, I'm saying 1 is a 0, or a root, or a solution. Those are all words meaning the same thing. Now, if we take a look at this function right here, if I ask you to find how many zeros it has, we look at the degree. The degree is 3, that means it has 3 zeros. If it had degree 10, it would have 10 zeros. What is one of them? Well, we already found out one of them. It was x equals 1. So if x equals 1 is a solution, or a 0, or a root, we need to figure out what the factor would be that would correspond to that. So if I say x equals 1, remember a factor looks something like, in parentheses, x plus some number, or x minus some number. So we have to figure out how we can change this into something that looks like this. So if I have x equals 1, normally we would just leave it as x equals 1, but I need the x and the number to be on the same side. So I'm going to subtract 1 from both sides. If x minus 1 equals 0, and right here is my factor. So x minus 1 is a factor. So if x equals 1 is a solution, or 0, or root, then x minus 1, notice the sign is different, is a factor. Real quick, if I said x equals 5 is a solution, then x minus 5 would be a factor. If I said x equals negative 8 is a solution, or root, or 0, then my factor would be x plus 8. Remember, the sign has to be different, opposite. So there we go. This is a process called synthetic substitution. Let me know if you have any questions.